Analysing actual values is an essential part of the diagnostic process. It's a good procedure to inspect each value, then promote a change to the value and ensure that the value changes as expected. As an example, this could be the acceleration of the engine when looking at injector opening time. You can make a note of any incorrect values, which will help you decide the areas that require further inspection. In this video, you'll learn how to access the data, change the ways the data can be viewed, store and record the data for later recall, and get help if you're unsure of what a value should read. From the Test Steps screen, highlight Actual Values and select Continue. You're now taken to a list of actual values available for this system. There are several ways the data can be viewed. A single value could be chosen with a check mark and Continue selected to view that value. The vertical scroll bars on the right could then be used to advance through the entire value list. I like to do this as part of my initial inspection and make a list of anything that could be incorrect. Alternatively, I can choose just the values I'd like to view on one screen. A maximum of 8 values can be selected for comparison. Place a check mark in the box for the values that you'd like to view. We'll select accelerator pedal position and throttle valve position. This will enable us to look at the request from the driver and the ECU's response to that request. The ECU should respond by opening the throttle valve. With those values selected, choose Continue to display the data. The values are displayed numerically. I can now start the engine, promote a change by depressing the accelerator pedal, and evaluate the response. You could see the values respond to my input, but it all happened rather quickly. The ET750 has some built-in functions to help with value analysis. Looking towards the bottom right of the display, there is a multi-function button. It reads maximum at the moment, but also when pressed will cycle through minimum and current. Pressing this button now will display the maximum value recorded by the ET750. Pressing once more will, as indicated, display the minimum value recorded, and pressing for the third time will return you to the live and current view. The Store button can be used to save these values to protocols for viewing or printing later. Viewing the data numerically, as we've just seen, is good, but it can often help to graph the values, and this is where Time Profile comes in. I'll select Time Profile. This now displays a graph of the actual value that we'd previously viewed as text. The y-axis on the left displays throttle valve position in percentage, from 0 to 100. Its range can be automatically set by pressing the Graph Function button here. The x-axis along the bottom displays time. Its value can be changed by selecting the Zoom button and choosing from the list of available options. As you can see, we have 2 values on the graph with the throttle valve position currently being displayed. Should you wish to view the other value, it can be selected from the list on the right. Dependent on the values being displayed, it may be beneficial to view a single value at a time. Simply return to the Actual Value selection menu. Deselect the values no longer required, returning to the Time Profile thereafter. Let's carry out another snap test on the accelerator position sensor, comparing its value to the throttle valve position. We'll return to the menu and reselect that component. I'll then move back into Time Profile and select a more suitable time scale using Zoom. I'll choose 5 seconds. I can now start the engine and snap the throttle. Pressing pause on the right halts the capture process, enabling me to analyse the graph to see if the data matches my action. Here we can see that it's just fine. As you can see, the pause button has dual functions, and if pressed again would restart the graphing process. When paused, additional function buttons become available. Using this left arrow, we'll step through the paused graph incrementally, while this one takes you to the start of the graph. This arrow will move the graph to the right, and this one to its end. The plus and minus signs in the centre enable you to zoom in or out. The floppy disk icon is a great feature, and when pressed, saves the graph as a recording. The recording can be replayed at will and is accessible within protocols. The recordings function is covered in main menu section in the protocols video. The last function here is accessed via the bin icon. When selected, this clears the contents of the graph, ready to start afresh. Okay, that's covered displaying actual values. But what happens when you're unsure of a particular value? Wouldn't it be great if we had some help to hand? You'll be glad to know you have. The ET750 has a wealth of information and it's never far away. Let's go back to actual values and see how we can access this. I've chosen radiator outlet temperature as our value of interest. Looking above the value, you'll see the text for its description in blue. The blue indicates technical help is available for this value. Clicking or tapping this initiates troubleshooting. The year range for the vehicle has to be selected. I'll select the second choice and continue. We can now see some specifications on the left for radiator outlet temperature. It gives us the sensor's maximum range as -20 to +120 degrees centigrade. One of my favourite features is activated by the button to the right. When selected, the actual value will be read from within diagnosis and displayed here. The arrow next to it can be used to insert the value next to its specification. Green indicates within its maximum range, red meaning it's not. Here we can see that it's just fine. Whilst our sensor appears to be in specification, it's possible that it's reading a plausible value but at the wrong time. The great thing here though is that the technical help brings this to your attention. We're asked here to check the plausibility of the actual value. The information directs the technician to raise the coolant temperature over 110 degrees centigrade and ensure the radiator outlet sensor reports a temperature between 60 and 100 degrees centigrade. I'll bring up the actual value selection list. Select coolant temperature and press OK. Now we have both values on the screen. I can start the engine, raise the temperature and monitor the values. As expected for our demonstration, both values are in range. Had the radiator outlet temperature failed the plausibility test, then further help is available as we're directed to carry out tests on the sensor circuit itself, along with the electric thermostat, as this could cause an incorrect reading as well. Even further assistance is possible from this screen via the Reference Info button. If an electrical test was required on the sensor circuit, then we'd need a wiring diagram and positional information. Selecting either of these options would take you directly to that data. That concludes the training on using actual values. Why not watch the next video in this section and you'll learn all about actuators and how using them can help in the workshop. Thanks for watching.